in this video, we're going to take a look at our double angle identities. And our double means twice. So our double angle identities are going to be twice a certain angle. Okay, so if you take a look at this, we have double an angle here, but all of our formulas here have a single angle. So for our cosine of double an angle or cosine of 2 times an angle, we have 3 formulas for that. Cosine of 2a equals cosine squared of a minus sine squared of a. Cosine of 2a equals 1 minus 2 sine squared of a. Cosine 2a equals 2 cosine squared of a minus 1. And I want you to take a look at this. The cosine of 2a on the left-hand side always results in an identity that does not have a double angle in it. It has a single angle in it. Okay? All right, so the sine of 2a is 2 times the sine of a cosine of a. The sine of 2a only has one formula, and it also results in a formula or an identity that has a single angle in it, right? These are trigonometric functions of a single angle. This is a trigonometric function of a double angle. All right, and then tangent of twice an angle equals 2 tangent of the angle minus tangent squared of the angle. So sine and tangent only have one identity. Cosine of 2 times an angle has 3 that you can pick from. Okay, so these formulas are derived from the sum identities. So for instance, to get cosine squared a minus sine squared a, what did they do? They took cosine of 2a and they changed 2a. Instead of 2 times a, they set it up as a plus a, so that you were adding 2 angles together. They could apply the sum identity, and that's how they got that formula. And the same with sine and tangent. The double angle formulas for sine and tangent. So let's start working through these examples. So this is from the first section, and this is just a matching section. So for when I do these, I'm just going to take a look at how these relate to our identities that we just outlined up above. Well, I know that this looks a lot like my tangent of my double angle, because the tangent of my double angle looks like this. All right, so, and that's exactly what this looks like. So this is 2 tangent of a over 1 minus tangent squared of a. So that means a must be 15. So when I plug a into this formula, we're going to plug in 15 degrees into all of this. Right? We get the tangent of 2 times 15, or 30 degrees, equals 2 times the tangent of 15 degrees over 1 minus the tangent squared of 15 degrees. So this is really easy to figure out, because you should know what the tangent of 30 degrees is. What's the tangent of 30 degrees? It's radical 3 over 3. And if you don't have that memorized, you can always draw a 30, 60, 90 triangle, right? You could label this 1/2 radical 3 over 2. This is 30 degrees. So it's opposite over adjacent. So it would be 1 over radical 3. And when we rationalize, it's radical 3 over 3. Okay, so that made it really easy to evaluate that expression, right? You know, once we pick the right formula, we know what the tangent of 30 degrees is. So how about this one? I know you guys know what pi over 6 is, but I do want to set this equal to one of my double angle formulas. So I know I've got a double angle formula that looks like this. And that equals the cosine of 2 times the angle. So in this case, a is going to be pi over 6. So when I plug that into a here, the cosine of 2 times pi over 6 equals the cosine of pi over 3. And what's the cosine of pi over 3? The cosine of pi over 3 is going to be just 1/2. So even though we could have done it the long way, we could have figured out what the sine and cosine of pi over 6 was and square it. I wanted to take a look at our double angle identities and compare it to one of those formulas. All right, let's box that one in. So now it says use identities to find the sine and cosine functions for each angle measure. So here we're looking for the sine and the cosine of 2 theta. And if I go back and I take a look at my formulas, okay, the cosine of 2 theta, really if I knew the cosine of theta, I could use this one right here, right? But the sine of 2 theta requires both the sine of theta and the cosine of theta, all right? So before I even start, I'm going to go ahead and use my identities to find the missing value. So it says I have a cosine of theta that's negative 12/13 and a sine of theta that's positive. So let's go ahead and use our sine squared theta plus cosine squared theta equals 1 formula. I'm going to plug in negative 12/13 into this formula for cosine. So I get sine squared theta plus 144/169 equals 1. So therefore sine squared theta is going to be 25/169. So it does say that my sine is positive. So sine of theta is going to be positive when I take the square root. I'm going to pick the positive square root, so it's 5/13. So now I have all the information I need to find cosine of 2a and sine of 2a. Well, sine of 2a is just 2 sine of theta cosine of theta. So let's go ahead and what is the sine of theta? 5/13. And what's the cosine of theta? Negative 12/13. So I know, if I do my calculations correctly, 5 times negative 12 is negative 60. Negative 60 times 2 is negative 120/169. So there we go. So the sine of 2 theta is negative 120/169. What's the cosine of 2 theta? Well, I can pick any of the formulas that I have for the cosine of 2 theta. So I'm going to pick the one that just has cosine in it, just to be safe, because if I calculated the sine of theta wrong, then I will at least get this one right, because they give us the cosine of 2 theta. So that's going to be, that's a squared, 2 times 144/169 minus 169/169. So that's 289 minus 169/169. So what do I get there when I do that subtraction? Let's see, 288, I'm sorry, 288. I'm going to get 911/169, which is a nice positive value. So I know that theta, because cosine of theta is negative and sine of theta is positive, theta is in Q2. But which quadrant is 2 theta in? And I know the question doesn't ask this, but sine is negative and cosine is positive. So that gives us a quadrant of Q4 for 2 theta. All right, so now let's do the next one. It says we need to find the sine of 2x and the cosine of 2x, given that the tangent of x is 5/3 and that sine of x is negative. So tangent I know is positive in Q3 and Q1, but sine is negative in Q3. So X is a Q3 angle. So I know for sine and cosine, my double angle identities require sine and cosine. So I'm going to go ahead and find sine and cosine by using my Pythagorean identities for just the regular angle. So I know that tan squared of x plus 1 equals secant squared x. So 5/3 squared plus 1 is secant squared. 25/9 plus 9/9 is secant squared x. 34/9 equals secant squared x. So secant is cosine. I know I'm in Q3, right? Because tangent is positive, sine is negative. So cosine is going to be negative here. So when I take the square root, I am going to take the negative square root. So secant of x equals negative radical 34 over 3. So that means cosine of x equals negative 3 radical 34 over 34. So now let's go ahead and find the sine of x. So when I plug that in, sine squared of x plus 9 over 34 equals 1. Sine squared of x is going to be 25 over 34. And so sine is negative in Q3, so I'm going to say the sine of x is negative 5 radical 34 over 34. So I need this guy and this guy in my formulas. So let's calculate the sine of 2x. 2 sine x cosine x equals 2. The sine of x is negative 5 radical 34 over 34. Maybe we should have used the unrationalized ones. Let's leave these not rationalized. And let's see how that works out. So this would be 5 over radical 34. And this would be just negative 3 over radical 34. Let's see how that works out. I mean, maybe we shouldn't, but we'll find out. It looks like it might be a little bit easier to not rationalize those. So 2 times negative 5 radical 34 times negative 3 over radical 34, which is going to be, that's 15 times 2 is 30 over 34, which is 15 over 17. So that looks a lot easier to not use the rationalized ones. So here again, I'm just going to use the cosine squared one. Yeah, I'll use the cosine squared one. 2 cosine squared of x minus 1. So cosine was negative 3 over root 34, and we have to square that and then subtract. So it is 2 times 9/34 minus 34 over 34. So 18 minus 34 is going to be negative 16 over 34, or negative 8/17. Okay, so I don't think we're going to have enough time for another example, but these are really good examples to work through. So I'm going to start another video, and we will start our next video on this example and then do a couple of verifications.